Jai Hind. Myself Sanjay Kumar Sonker, Assistant Professor in AKGEC Engineering College. In this lecture, we discuss about the theory of automata and formal languages on the topic of grammars. We discuss and talk about the grammars. Same the grammars is using to the English languages, Tamil, Hindi. We are using to the grammar to generate the languages, and this languages is accepted. So many same terms as we generate a languages, and languages accepted in a theory of automata. We discuss about to the grammar. The first we how to describe the grammar. Grammar describe as a languages, and languages is generated by the grammars, and languages accepted by the machines. Now, how to express the languages? The languages is expressed by grammars. Now we discuss about how to generate a grammar. Grammar generate a language, and language is accepted by a machine. Yes. Next we discuss about grammar expressed by languages, and languages accepted by machine. Next example we discuss as a English language, Hindi, Tamil, Telugu. There is so many languages generated. The set of rules is known as a grammars. We discuss the sentence generate the noun phrases and predicates, and again noun phrases is generated articles and nouns, and predicates is generated as a verb. Here the articles is terminate with a, articles again terminate with the, noun is terminate with boy, dogs, and verb is terminate with runs and walks. That is a verb. So many articles and nouns are stored in a dictionary. Here we just take a example, that is a alphabets. Alphabets generate a word, and words is generate the sentence. The alphabets is limited. This definition of alphabets are given in the dictionary. It's generate a words. Words are limited, but the sentence is infinite to generate using with the word. This sentence is generated with the help of grammar. Here we are using to grammar to use the rules on a words and generate the sentence. Next, another derivation. What is the derivation? Derivation is a process to drive the string. It's known as a derivation. The boy walks. This derivation is a strings is generated by grammars is given as a rules. Sentence rules is given as a generate the noun phrases, predicates, noun phrases, predicates again generate verb, noun phrases generate articles and nouns. Next is articles generated as a the, that's a terminer, that's a terminate the articles, nouns, verbs. Next, noun is again terminate by boy, verbs, and verbs is terminated with walks. Now we read the left to right, that's it, the boy walks, that is a sentence. This sentence is generated by the set of roots is given here, that's known as a grammar. Grammar is a rules and generate a sentence. Here there is a languages of a grammar. There is a languages is given. There is a language is finite or infinite. Language is a finite for a finite words to generate. Now with the notation is given as a, there is a noun generate a boy. That is a production rule. Production is given as a noun generate a boy, same as noun generate a dogs. Here noun is a variable, is also known as a non-terminer, that is a production rule, and right hand side is a terminer, that is a terminer. There's information is stored in the dictionary. Now another example of a grammar. I just take an example of a grammar to generate a string or drive a string, drive a sentence. Here same as variables s is generate a S, B. A, B is a terminer. Now we define as a grammar is defined as a set of a terminers set of a variables is given as S, start symbol is also S, and production rule is given as a S, A, S, B and F lambda. Clear? That is defined as a grammar. Now, how to generate a string or sentence using to the Sentinel form of a grammar? We just use the start of the symbol of a grammar. S is the start of a symbol. The S is produce A, S, B. Now we replace the S by epsilon. The string is generate AB. Epsilon. That is the string will be generate AB. That is the first string. And S is also generate lambda. So his language is given as a first is epsilon, next string is AB. Now we again recursively used S same as A, S, B. Again we replace S the starting production A, S, B, B. This again we put the epsilon A, B, B. Next string is A, B, B. The language is finite or infinite? The language is infinite to generate. The same number of A and same number of B will be generated for a given grammar. Same as, that is the derivation. There are the same number of A and same number of B's. Number of A is equal to the number of B's. Generated languages. We also define a language is defined as a number of A is equal to the number of B's generated by this languages grammar. Okay. Now also we write it same as A ki power n, B ki power n, n is greater than equal to 0. That is a language. We can also write it same as. Now same languages, same grammar, we generate this language. We are using to the derivation and derivation tree. Derivation is a process to drive a string, and derivation tree is the graphical representation of a generate a string. Now we just draw the derivation tree for a given grammar to generate a language. We are using to the start symbol S, A, S, B. Now we recursive again put the same production A, S, B and so on. And the last we are put it lambda. Now there is a n number of A ki power n, same as B ki power n we are generated. So A ki power n and B ki power n, or n is always greater than and equal to 0. This language will be generated. We read from the left to right of the tree. Now more annotation about to the grammar. Define as a 5 tuples. We can define a grammar. V is the variables, is a finite set of a variables. T is a tuple, that is a finite set of a terminals. S is a start symbol. P is the production rules is given in a grammar. I just take an example for a grammar. To generate a language, start with A. The language is start with A, B, A, finite or infinite, language is infinite. Now we just drive the grammar for the languages is generated. So we define a grammar as A is a variable, just A of A, B of A and epsilon. Now this is a grammar. Let's take an example to generate a language starting with A. Now we just use the starting with starts symbol is S, A, drive a derivation tree, again put a A and any number of A and B. After that, any number of B's and the end epsilon. We read the derivation tree from left to right. The result is A, B and epsilon. This is the grammar to generate the languages. There is a now next we define how to define the grammar. We are using as a here we define a grammar. Grammar is given as production is A. 1 second. Next A is A starting with A, B, A and epsilon. Define as the same as notation of a grammar is defined as variables. Here variables is a as a set of a variable, non-empty set of variables is as a. Terminals is given as small a, small b and epsilon, that is a terminer. Start symbol is given as is a start symbol defined, and production rule is given as production A. Next is A, B, A and epsilon. That's defined as a grammar. Next, we discuss about to the more detail in a grammar. We discuss about the Chomsky hierarchy in a theory of computation. Here we discuss the grammar is classified on the basis of a classes. There is a given a different classes is type 0, type 1, type 2 and type 3. Is also known as a type 0 grammar is also known as a unrestricted grammar. Unrestricted grammar is generate the recursive enumerable languages, and recursive enumerable languages accepted by tuning machine is known as a universal machine. Next, type 1 grammar is generate. Type 1 grammar is also known as a context sensitive grammar. Context sensitive grammar is generate the context sensitive languages, or this language is accepted by the linear bound automata. Next, we discuss type 2. Type 2 grammar is also known as a context free grammar. Context free grammar generate a context free languages, or this languages is accepted by the push down automata. Next we discuss, next is a type 3 grammar. Type 3 grammar is also known as a regular grammar. Regular grammar generate a regular languages, and regular languages accepted by finite automata such as a NFA, DFA is accepted the regular languages. Same as we discuss about the type 0. Type 0 grammar is known as unrestricted grammar. There is a no restriction on a production rules. Is known as a recursive is generated recursive enumerable language and accepted by the machine. Type 0 grammar. Next, inside type 1. Type 1 is a context. It's known as a unrestricted grammar. Context sensitive grammar. Type 1 is known as a context sensitive grammar, generate a context sensitive languages accepted by the linear bounded automata. And type 2 grammar is known as a CFG context free grammar, generate a context free languages accepted by the push down automata. And type 3 is a regular. Type 3 is a regular grammar, generate a regular grammar, generate a regular languages accepted by finite automata. There is a Chomsky hierarchy. Now we discuss in detail of type 0 grammar. Type 0 grammar is also known as a recursive enumerable grammars, या phase structure grammars, या unrestricted grammars. We are just normally we are called as a recursive enumerable grammar. We mention as a recursive enumerable grammars. Okay. Now, recursive enumerable grammars used to generate a recursive enumerable languages. It's generate a recursive enumerable language, or this language is accepted by tuning machine. Now, how to define this language? Using to the some mathematical approach for a given production of alpha produce B beta, that is a alpha generate a beta. For define a left hand side and right hand side. Left hand side at least one variables we are using, and left side we are using to sigma union Vn clean closure, or right hand side is sigma union Vn ka clean closure. At least one variable are using to the right hand side, and the right hand side there is a no restriction, or left hand side also no restriction, or same as right hand side no restrictions. There is an unrestricted grammar, both side there is a no restrictions, and or same as it's a definition of a grammars also. We'll just take some example. There is a no restriction of a left hand side. We are using to the sigma union Vn ka clean closure. We are also using the epsilon, or we are using to A, B, and right hand side there is a no restriction. We generate AA and BA, that's a universal, unrestricted grammar. That is a very complex grammar. This types of a grammar is generated very complex language. That is a simple grammar. This is generated complex language, and complex language is accepted by tuning machine. Grammar is easy, but generate the language is very complex. Highly complex language is accepted by tuning machine. Now we discuss about the type 1 grammar. Is also known as a context sensitive grammar, या length increasing grammar, या non contracting grammars. These types of grammars generate the context sensitive languages which is accepted by the linear bound automata. Is defined as a context sensitive grammar generate is also known as generator, is generate a context sensitive language, or this language is accepted by linear bounded automata. Now we define as a mathematical terms. So production is given as a alpha generate beta. Here we are restriction on a right hand side, but not the restriction on a left hand side. There is a no restriction, only restriction on a right hand side. There is not include to the epsilon, same as the also known as a non-contracting or length increasing grammar. Length of a alpha production is always less than or equal to the length of right hand side. Just take an example to easily understand. If we are generate a grammar as a epsilon, now we can check the length of right hand side and left hand side, and right hand side is length of A, and also we check the length of epsilon. Length is 1 and this is the length is 0. This is not satisfied this mathematical expression. So this types of grammar is not in type 1 grammar, but if this types of grammar is also in a type 0 grammar, but not in a type 1 grammar. Now we discuss about type 2 grammar. Is a context free grammars. Context free grammar generated context free languages, and context free languages is accepted by push down automata. Now we define the mathematical expression is the production is alpha generate a beta. This types here the length of alpha, the restriction on the right hand side, left hand side, the restriction is left hand side, restriction on a left hand side is only a single variable, only single variables, but there is a no restriction on a right hand side. There is a no restriction. We can generate sigma union Vn ka clean closure. We can generate any terminal, non-terminal here in a context free grammar. Next is a regular grammar. Regular grammar Regular grammar is generated regular languages. Regular language is accepted by finite automata. Grammar is a complex. Grammar complex. Language is simple, accepted by finite automata. That is a meaning. Here, regular grammar is classified with two types: is a linear, left linear grammar and right linear grammar. Left linear grammars, only one left hand side only one variables, right hand side only one variable. That is a restriction. In a left hand side and right hand side only one variables. The length is always 1 and A belongs to sigma star closure. That is any generate any string using with alphabets. That is a left linear. Next is restriction on a position of right hand side is variables is leftmost, always in a extremely left here. This types of a grammar is known as a left linear grammar. That is a B, A and B. There is a leftmost. Variables is a extremely leftmost. Next, right linear grammars. Both the same is both side is a one variables and right hand side variables is rightmost. This types of a grammar is known as a right linear grammar. Now another example we same as example we are also taken. That is the derivation is also known as the combination of a terminer and non-terminer variables is known as a centener form of a production. Derivation is a sentence, generate a sentence. Here is any derivation, we are generate a string. Any derivation centener form to generate a string. Same as we generate a string here. As again we replace the value of A as B. Again we replace S as A as B, and next we replace A as epsilon. The sentence will be generated, a string will be generated A B B. There is a n number of A and n number of B's, and n is always greater than or equal to 0 for a given grammar. Same. Another example. Now we take another example to derivation. We just draw the derivation and derivation tree and centener form of the grammar. Now we define the centener form to generate a string. Here we just check the start symbol of a grammar is S. S is a start symbol. We define as a grammar first. First we define a grammar. Variables are given here A and B, and lambda is a variable. A, B, lambda is a terminer. A, S is a variable. And start symbol is S. Production is given here. There is a production. Rules is given as A, B, A, B, A, lambda. That's defined as a grammar. Now we generate a string. Now same, this is a production rule given to generate a string using with the centener form, derivation and derivation tree. Here we define as a derivation A. We are using to the start production A, B. Now we replace the A with A, B here. Now we A is epsilon. We are using A production as a epsilon, that generate a string A, B, B. Okay. Now we discuss the next class. Continue. Thank you.